All right, so we have a differential equation of this form over here, where the derivative of y with respect to x is a function of y. It's missing the independent variable of x. It's called autonomous. Right. This is an example of an autonomous differential equation. And I certainly, I'm going to say, graphing out the slope field for this thing, you could do it if you want. It doesn't depend on x at all. Probably going to be easier to graph out, but you could use a machine to do that. But I'll be honest, even if you looked at it, I don't think you'd know this is a solution to the problem. So I'm going to say it's given. Now again, I'm going to say that part of reading is just understanding what you just read. I mean, they gave you a differential equation. They gave you a new name here, autonomous. There's no x in that. And then they say, oh, the solution to that problem is, this thing here, which I don't think you'd get from the direction field. But it says it's a more difficult example, all right? And I think it is. All right, so go on here. Now I want to verify a couple different things, and one thing I want to do is I just want to verify the derivative over here. I want to verify that, right? So let's do that, because it's part of verifying it's a solution, by the way. So let me write down what y prime is, and I'm doing that by doing this over here. And let's write that down. And what's that going to be? Well, 1 minus k e to the x quantity squared. Bring the bottom to the top, times the derivative of the top, which is going to be k e to the x, minus the top. That's 1 plus k e to the x, times the derivative of the bottom, which is going to be minus k e to the x. So I'll just put the plus down. Now, if I simplify that, which I want to, not much I can do about the bottom. If I look at the top, I'd have k e to the x plus k e to the x, which would be 2k e to the x. And then, I'd have minus k squared e to the 2x plus k squared e to the 2x. They disappears. So I'm going to say this is verified now. All right? Here's what it says to do now, though. It says, plug it in. See if that's true. So it says, what do you mean you plug it in? This is the equation, the differential equation. That's the solution. What are we going to do? We're going to plug this derivative in here and see if it's true. Now, again, they say the algebra might be too much for some students, but I still want to give it a try. I still want to give that a try. So let's talk about trying that. So I'll write that down for you. And I got y prime. It's right here. What I'm going to do, I'm going to plug it in right over here. It's going to be 2k e to the x, 1 minus k e to the x squared. That's what y prime is, right? What do we get over here? You get y squared. Well, what's y squared? It's right up here. We'll do that later, minus 1. I want to try to isolate that y squared. I'm going to multiply both sides by 2. I get 4k e to the x, and then I get 1 minus k e to the x, quantity squared. I multiply both sides by 2. I get y squared minus 1. All right? And again, what's y? This is y. Let's write that down. I'm sorry, I made a mistake already. We're going to square it. We're going to take 1 from it. All right? So I'm looking at this thing. I'm wondering, is that really true? And that can be a problem. So what I want to do is I want to erase this business over here. I don't need that anymore. I'm wondering if that's equal. And the way I'm going to do that, I'm actually going to clear the fraction in the problem. And I'm going to multiply both sides by the LCD. And the LCD is 1 minus k e to the x squared. What would you get? You get 4k e to the x equals 1 plus k e to the x squared minus, again, we're multiplying by the LCD, 1 minus k e to the x squared. Well, this is like a deja vu all over again. I think we just did that, didn't we? But let's go through it. 4k e to the x. What do you get there? You get 1 plus 2k e to the x plus k squared e to the 2x. Let's do this, but I'll put the subtraction down. It's going to be 1 minus 2k e to the x plus k squared e to the 2x. Well, if you pull them all together, what do you get? The 1's disappear, you get 4k e to the x, and the k squared e to the 2x is minus k squared e to the 2x disappears. So it's true, all right? So I'm going to say it worked as advertised. It really did work, all right? So next up is going to be like an initial condition in the problem. So let me just say, I'm really going through these notes as if I were studying. Let me erase this business over here. So I'm convinced that although I probably couldn't get the solution to this, I was given a solution, I just checked it, it worked. Right, worked nicely, by the way. And now they're giving me an initial condition. And let me tell you what that initial condition is. The initial condition is this over here. So we want to figure out what the k is, given this information over here. That y0 equals 2. Let me go back over here and write this down for you. Let me erase this 2. Well, what I'm going to claim over here is if y0 is equal to 2, that means the x is 0, the y would be 2. And I think I can figure out the k now, which is going to give me a specific solution to the problem, not a general one. Okay, let's write this down. And what I'm trying to do is trying to figure out what the k is. That's what I'm going to do now. So the y is 2. You get 1 plus k. Well, e to the 0 is 1. On bottom, what do you get? 1 minus k. And again, e to the 0 is 1. This looks pretty simple. I multiply both sides by the LCD. What do you get? 2 minus 2k equals 1 plus k. Take 1 from both sides, you get 1. Add 2k to both sides, you get 2k. So what do you get there? I get k is 1/3. So I got my solution now. Let's write this down. So y equals 1 plus 1/3 e to the x. On bottom, you get 1 minus 1/3 e to the x. I don't like the way that looked. I'm going to multiply top and bottom by 3. What do you get? Y equals 3 plus e to the x, 3 minus e to the x. That's my solution to the differential equation. Well, let's take a look, see how we did, and see if we got the same answer that's in the K. And again, work is written down for a reason, by the way. We got this written over here. So anyway, you got 3 plus e to the x, 3 minus e to the x. So let's look at the picture. And again, I'll go through how to generate that using Grapher software. So anyway, figure 4, page 7 of the above problem, and see what happens over here. So that's figure 4 on page 7. Let's go to that. Right over here. So, I mean, what's being plotted out? The direction field, that's what's being plotted out. And the solution that contains the point, 0, 2. That's the point. Again, what's the solution over here? I graphed this curve out. And again, I will go through that with you. What was that going to be? That was 3 plus, let me make sure I'm saying that right, by the way. 3 plus e to the x. And the bottom was 3 minus e to the x. And we did graph that out. But I'll go through that. Thank you.